promote things that are upcoming. So with that, I'm going to stop sharing and pass it over to Mark and Cliff from Vanderbilt.
Oh, thank you so much. I'm going to do the first bit, but Cliff is going to be doing the sharing of our slides. So thanks, Cliff. And this is, as you can see, Exploring British Periodicals with Databricks. It's a project that we're in the midst of, and it's in a way the story of how a really highly collaborative project stemmed out of what began as just an individual research project I was doing, and how Databricks has contributed to making that expansion into collaboration possible. So next slide. So my focus actually is on a research project on litigation and what understanding the periodicals of the Romantic era, my specialization, can do to help fill in a lot of gaps about what we know about litigation in that time period. So I began just looking at, yes, next, British periodicals. And this is just to clue people in on it. British periodicals is basically a database of about 3.4 million articles divided across about 400 journals that have been collected. And this just shows this slide. If you look up legal in the time period I'm interested in, 1770 to 1835, you can see there are 20,000 plus journals that have the word legal, but it's very hard to tell from this which are the important ones, which are the ones that would be resonant with one another, and so forth. And that's where trying to use, not just reading, but next slide. Cliff, this just gives you a view of one aspect. So this is just what we see when we just pull up an article in British periodicals. We actually get the PDF of it. And this is an article having to do with one subsection that I'm really interested in, and a number of our students, I think, gravitate to, which inventing paupers out of poverty. That is, how did the conceptualization of paupers as a legal category come out of the production of impoverished people in Britain. And the periodicals have a lot of interesting things to say. And again, it's a question of how do we sort of get at what they're saying in a way that goes beyond the kind of close reading that would be possible, since there are, thousands of documents for any one given one of these. Next slide. Databricks is one of the things that has really helped us do it, because what it allows us to do is set up notebooks that let us work with students who can explore sub-aspects and the students can have varying levels of computer experience. They can have different goals. One way I sort of think about it is that the notebook environment lets us give enough control over what the students can do that it lets them be really creative within that control. They can ask different questions, think about different methods, and the nice words, you can always tell them you can't break anything. Next slide. And just to wrap up, I want to give one sort of specific problem that we're in the midst of, and in a sense, one problem to rule them all. And that's the question of trying to improve the OCR. And this is just an example. On the left, you see the PDF, and the right shows you the OCR that came out of it. And you can see some are very specific. You don't need to worry about the details, are sort of predictable problems, getting F's and S's confused. Certain letter combinations, OCR is really bad with. And we're hoping to find ways of transforming this more generally. But let me now, leaving that hanging, pass it off to Cliff, who can sort of fill in our journey from the kind of combination of the technical side of it and the people side of it. Cliff? Mm-hmm.
Yeah, thanks a lot, Mark. And this has been a really collaborative, wonderful project to work on that includes several other folks at Vanderbilt as well. And so one of the things that I just want to kind of talk about from my perspective as a librarian is sort of how Databricks fits a really important need that I think more and more libraries are coming to realize they have, which is what I would call the data licensing to data analysis pipeline. And we, when Mark came with this project and said, we want to analyze these, 3-point-something million periodical articles, we licensed the data and acquired it from ProQuest, and it arrived on 3 hard drives. And then the question was, well, now how do we get to the point where we can do that analysis? And so we tried various paths. The obvious first path was just to put this into a large database and provide it with the resources necessary. And that actually did work. This is not big data on the scale that you can't handle it in a single database, but it was hard to get the students connected to the database in the way that they could use their notebooks, and it was hard to connect the machine learning tools that we'd like to use, the natural language processing tools. And so we found that was not our best path forward. It was actually, there was a lot of complexity about getting the database to the students in the way that they could do their analysis. So then, we moved to Apache Spark, and I will just say that, our initial way of starting with Apache Spark, because we had Amazon Web Services available to us, was to use the Elastic MapReduce Studio, Amazon EMR, which worked very well, except that it required the students to go in through the command line to do their work. And a lot of our students who are coming from literary studies just didn't feel comfortable on the command line. And it's also somewhat difficult for us to troubleshoot each of their individuals' environments on their laptops or whatever to make sure that the command line was set up properly and they were gaining access. So a lot of sort of setup headaches that were taking up a significant percentage of our time. The other problem, you may know that Amazon has a tool called Elastic MapReduce Studio, which does allow us to attach notebooks to EMR clusters. But we're also trying to use the John Snow Lab Spark NLP libraries, which are wonderful, and we've had really great experience with them. But we couldn't get those to work because of a bug in something called Apache Libby in the EMR Studio environment. So we kept hitting walls and walls and walls. And this is where I have to give a shout out to Rob, because he really kind of saved us from this. And thank you so much, Rob, for including us in this university program, because Databricks has really provided like the sweet spot of like the sort of being able to connect all the tools that we want, the John Snow Lab tools, making sure that students can easily access them through notebooks. Typically they can get started in a single session. We can explain everything they need to know, and then they're set up and ready, which is great because then we can really concentrate on the problems. And it's also what's really great is it allows us to develop different tracks. Some students are maybe less technically sophisticated; they never programmed before, and so we use mainly SQL with them. And the beauty of sort of the ease of use of SQL within Databricks. We just taught a class session on that yesterday, and students who had no background on it were already kind of playing with SQL expressions to find different results. And then, of course, for students that have some Python experience, we can introduce them to PySpark and the machine learning tools and take it from there. So all in all, I think it's been a really wonderful way to encapsulate all the requirements for the project that Mark discussed, and then being able to help students to quickly come on board and feel productive as well, to work alongside us to solve real literary problems. I will stop there because I want to hear other people's talks, but thank you again for the opportunity to speak with you all, and I hope there are questions later in our session.
Yeah, thank you. Thank you, Mark and Cliff. We're getting some good comments on LinkedIn, and I think just seeing the type of problem that you are attacking with Spark is interesting, and to be honest, it's a delight to work with Mark and Cliff. So I'm just happy that I'm useful to them. So with that, I will turn it over to Judita from Salford.
Hi, everybody. So I'm going to describe our path to using Databricks for our teaching. So I'm at the University of Salford in Manchester. We have an MSc in data science. which is a conversion course. So not all the students have an IT background. In fact, very few do. And it started in 2016. I think the first cohort was 14 students, and now we're capping it at about 200, 250 students. The whole course has 4 modules, and there's a live project as well. So that's within a company setting. And one of the modules is called Big Data Tools and Techniques, which is the one I deliver, and that's by far the most applied. The future of the course is also to integrate it into our new LSC in AI, which is going to have the added feature that the students will have a computer science background. So we needed something that was going to allow us to be flexible enough that students who haven't got any background in computing are going to be fine, and students who do have background in computing are going to be challenged. So we started off with virtual machines, but had many issues there, with particularly with students who didn't have enough computer experience. Too many problems. We were focusing on solving problems with virtual machines rather than actual problems that students will be encountering when they're programming. So we then moved to the Databricks Community Edition, which shifted the focus of the course more towards Spark, although we still do cover Hadoop and that side of things by porting the Databricks SQL versions to Amazon EMR. The nice thing is that we can use Databricks online, so we don't need students to have any specific machine RAM or hard disk requirements. They don't need to install anything, which is great, because we had a lot of students coming into the university to use the machines at the university to be able to run the virtual machines, which would have made it impossible last year when students suddenly had to shift to working from home, or learning from home. The other nice thing is, obviously, it's very consistent. We can run the student's code without having to worry about it potentially being on a slightly different version or requiring something that we haven't got. So I always make sure that all the students submit all their work and we actually do run it, and it's very easy with Databricks. So the module's got 2 main components. There's a kind of guided side to it, and then there's a bit of independent work. So they get everything. They get us with them, helping them do their lab work, which they then hand in as homework. And they can do that either on campus with us there, or we did it very successfully last year with online. And for the homeworks, we give them partial notebooks that they just upload to their Databricks accounts, complete it, it guides them, checks their answers, and obviously it's compatible with our auto grading as well, which is nice. And for their independent work, they're given an assignment for about 9 weeks. It's a largest data set, ideally on Databricks. So last year we used the Core-19 data set, which is on Databricks. They're asked about 6 questions that they have to answer. That's kind of the basic side of the assignment. But then they have to do some extensions to go beyond that. And that's nice, because it allows them to use all the various tools that are available to them. Like last year, because they were using Core-19, they could analyze the text within the articles themselves, and all the tools are there for them. So on the side of the Databricks, we're introducing Terminal on Unix. We're using the notebooks, so they don't have to worry about compiling or running anything from command line. And then there's the AWS backend side. And with their live project, which they go on to after they've completed all the modules, quite a few of the students have then gone on to companies that use Databricks already, or students have suggested that they go on to use Databricks. So that's been very useful to hear back from them. And this year, because we're now up to somewhere over 200 students, we're using the Databricks Enterprise option with some underlying AWS credits that we've been given. So initially I was thinking we'll use this as a backup to the community edition, because we've got so many students, it was sometimes taking quite a long time to start up the clusters. But I think what we will use it more, because we've got quite short lab sessions, about an hour and a half, but we can make sure with this, we can make sure that we've started up the clusters for them. So we're going to try and use that this year, and I can report back next year. Thank you for listening. I look forward to the questions.
So to fill in one or two responses here, Udita's teaching came to my attention, and it was more around the fact that Community Edition, the free version of Databricks, was having startup issues, and I don't remember the exact problems, but basically it had slowed the class down to a halt. For schools that are members of the Databricks University Alliance, we can actually set up enterprise versions of Databricks if you can bring either AWS or Google Cloud resources to the table. Occasionally we get, usually every 6 months, we get a small grant of credits from AWS. And thankfully in this instance, I was able to grab one of those credits and set up an enterprise account for Udita. So it's a great example of, and I think Robbie will be talking about this and showing you what the environment looks like next. It's an option for teaching that can actually be more effective. So with that, I didn't mean for that to be a segue, Robbie, but I'm going to stop talking and turn it over to you. Thank you.
No, that's perfect. Thank you. So let me go ahead and share my screen. Let's see here. Okay, so first, thank you to Rob and Karen for organizing this. So my name is Robbie Beane, and I'm an assistant professor of data science at Maryville University in St. Louis, Missouri. And today I'm going to discuss the big data analytics course that I developed for Maryville and how I use Databricks within that course. And I'm going to focus primarily on how I manage the course within Databricks. I think that for anybody considering using Databricks within their course, hopefully this will show you one version of what that might look like. And specifically, I am using the Enterprise Edition. I did start with the Community Edition, but I'll be demonstrating the Enterprise Edition today. So to give you a brief overview of the course I developed, it's offered at both the undergrad and graduate level in both a traditional on-ground format as well as an 8-week, a traditional on-ground format as well as an 8-week online format. The course covers general concepts relating to distributed data analysis, as well as the use of Apache Spark to perform large-scale data analysis and machine learning tasks. To give you just a quick overview of the structure of the course, we start out with an introduction to Spark and distributed data analysis. We discuss how to program with RDDs. Then we move on to data frames. We spend a little bit of time covering machine learning, and we close with a short introduction to streaming applications. So the advantages I have found to using Databricks, both the Community Edition and the Enterprise Edition in my classes, is that I can provide students with a no installation platform that allows them to get up and running as quickly as possible and exploring course concepts. And it gives them access to clusters of virtual machines to run their applications on, as opposed to having to run things in sort of local mode. But I also, one particular advantage I found for the Enterprise Edition is I found that it works very well as sort of an alternate learning management system. I've been quite impressed with how well suited it is for use in an academic setting. I use it to deliver course content to my students, to assign and collect homework assignments, to give them feedback, and they also complete their work directly within Databricks. So I'm just going to give you a quick tour into what one of my courses looks like. So this is a Databricks workspace that I set up for the on-ground class that I taught last fall. So most of the content that I delivered to the students is available within this workspace tab. And at the top level, I have several folders. Some of these are accessible to students. Some of them are only accessible to instructors. So for example, I have this lessons directory. Let me zoom in here a little bit to make sure that this shows up well. So for example, I have this lessons directory that contains notebooks for containing the lecture content. So for example, the first one is an introduction to Spark.
Robbie, I don't think we can see what you're showing.
Oh, okay. Thank you. Let me, what are you seeing?
We're seeing Databricks, Data Science and Engineering, the landing page.
Oh, okay. For some reason, it didn't update when I switched the tab. So let me try this now. Are you able to see the Databricks now? Okay, that's weird. It's in the same window, but when I switched the tab, it didn't update. Okay, I apologize about that. So this workspace tab is what I was attempting to show. This has some directories at this top level. And in particular, I have this lesson directory that contains the lesson content for the course in notebook format. And so these notebooks contain markdown cells with formatted text. Sometimes I'll embed videos, mathematical formula, things like that. But they also contain, for anybody familiar with like Jupyter notebooks, this is going to be a very familiar kind of setup, but interspersed with the course content or the lecture content, I have executable code that students can run to sort of demonstrate the ideas being discussed within that lesson. This directory is read-only. The students are able to access it, but not execute the code or edit it. However, I encourage them, the very first thing they do in the course, to clone this to their individual workspaces so that they can have full access to edit the code and explore it as they would like. When I'm teaching on ground, I will often make some of those edits in real time in class. And so I have an alternate version of this folder where I will kind of mark up and make alterations to it to explore, to kind of go along with the course discussion. And I make that available to students as well so that they can see any edits that are made during class. The homework and projects directories are not available to the students. These have solutions to the assignments. These are there solely for instructors to assist them in grading. And office hours it just contains notebooks that I create in real time during virtual office hour meetings. And again, I share those with students. When you click on the users directory, you'll have access to all of your students. This is one thing that is not easily available or not as conveniently available within the community edition. So I have one directory for each student. And by the way, students are only able to see their own directory. They don't have permission to see other students' work. And so to give you an idea of what this looks like, I'm just going to click on, so this isn't a real student. This is actually my email address. But students will typically have 4 directories within their workspace. They'll have a homework directory where they will create notebooks to submit their homework assignments, to complete their homework and submit those assignments. A similar directory for projects. Lessons will be their own local copy of that lessons directory. And then a sandbox just for them to explore ideas. They can use that however they wish. When a student completes a homework assignment, I provide them with a PDF that gives them instructions of what I would like them to complete. And then they create the notebook from scratch and then add headers and things like that to give it some nice structure, and then address the questions within that PDF. And then when it comes time for me to grade it, I will make a copy of the notebook, and then I will append the word graded on the end of it. And then I will go through and execute their code from start to finish. If there are any mistakes, I will update that code and add comments for them. So if you want to see an example of a grading comment I might add, it would look maybe something like this, something to kind of really get their attention. I'll tell them what is incorrect about their code, maybe like what correction to use, things like that. And I find this system works very well. Though I guess one last comment, the one thing I do, there is no way, at least that I'm aware of, to set like due dates or anything like that within a Databricks, and there's no way to lock them out of editing an assignment once a due date hits. So just to sort of, for their official submission, what I ask them to do is when they're done with a homework assignment, I have them export it in an HTML format and then upload that to Canvas as the official record for their assignment. And then I tell them not to make any updates to the assignment after they've submitted it. Unless, like, if they do want to do that, then make a copy in the sandbox, and then they can continue to explore the assignment however they would like. Okay, so that is really all I have. I'm happy to discuss some additional aspects of the course and answer any questions that you might have, but this is probably a good place to pause.
Thank you, Robbie. I actually learned a lot watching what you're doing. And Scott, I apologize for missing your question earlier. Scott Jensen from San Jose State asked Udita, what tools are you using for auto grading? So Udita, if you have comments or enhancements or differences from what Robbie is doing, it'd be great to hear about those now in this context.
So we normally use NBGrader just for auto grading. So I set that up on my own machine. Students are given the notebook, and then they export that again. That is auto graded. I think I grade that on my own machine again.
And how many students do you have, Robbie, roughly?
Our sections are usually capped at around 18 or 20 students. So individual sections are pretty small. We might have 3 to 4 sections in a given term, but typically it'll be different instructors responsible for those. So I haven't actually explored auto grading in my classes because it's pretty easy to grade that work for that small number of students.
Yeah, and if we look back in the slides, Udita is probably an order of magnitude greater in terms of number of students. So
yes,
it's good to know the difference. Wonderful. Thank you so much. Any other questions for Robbie before we move on to Roz?
I have a quick question for Udita. So when she's doing the grading locally, so the students are working in Databricks, and I guess they export it as source file or DBC archive. And then when you set it up, your own autograder internally, I guess you're using either source or DBC archive. If you use the latter, then you have to do some inverse parsers. My more important question is, when you try to grade locally, what if the data set is really big? And then it's very difficult to get a local cluster to have a large data set.
So I can answer those. So we have the same setup, I think, that Robbie just described, that students are asked to upload something, their notebook that they've downloaded from Databricks onto a local Blackboard system, what we use instead of Canvas. I just automatically download it from there and then run it on my own machine. That can run on whatever data set I've set them. So I can actually run the solutions on there. It just runs through them in one after the other, or through 200 students. It just goes through.
I guess my question is, you're asking the students to download as source file, right? Not as HTML or as .dbc archive, right?
IPINB, just a notebook.
Oh, the iPad. Yeah, okay. Then it's all just Python. So then in the Python ecosystem, yeah, that's okay. I see. Oh, yeah, it makes sense.
And one question for Robbie before we turn it over to Roz, again from Scott Jensen. Robbie, do you know your average cost per student for the AWS credits? This helps me benchmark when I have conversations with AWS as well. So go ahead.
Yeah, so far I have limited students to fairly small clusters, and the cost has worked out. I mean, so it varies depending on whether it's an 8-week course or a 16-week course and things like that. But just roughly speaking, I would say about $8 per student per week is what the costs work out to be.
Thank you. All right, so Roz, take it away.
So can you see Uppsala University on the browser?
Yep.
Hi, I'm Roz. I'm in Sweden at Uppsala University in the Department of Mathematics. Here's just a bit about me. I'm associate professor of mathematics with specialization in data science. And this is basically my research and teaching page. And what I mainly wanted to show was this sort of set of teaching content. So I've been involved with Apache Spark since 2015 and with Databricks since 2016. And here are various instances of these courses that have been running for quite a while. The latest instance I'll talk about is SDS 3.x. And this instance is called Scalable Data Science and Distributed Machine Learning with Apache Spark 3.x and 2.x. And the acronym is Karamali. The last instance of the course that ran with roughly 60 or so PhD students in the voluntary autonomous software and AI program, the AI track. I took this course. It's one of the mandatory courses for the artificial intelligence track. And in this instance, Karamali is broken up into 3 modules. One is called Introduction to Data Science, Fault-Tolerant Distributed File Systems and Computing. The second one is Distributed Deep Learning, both theory and implementation of distributed deep learning. And then the last module is called Decision Making with Scalable Algorithms, which is basically where students form groups and do projects on their own research area, whatever it is, and we try to field them. So now I wanted to show that all of this content is available in here via GitHub. So, but it's kind of a zoo to just directly go there. So before I dive deep, I want to show you the course pathways because it's a slightly messy directed acyclic graph because students take the course from the current instance that will start in March is offered to anyone in Uppsala University. We have 3 divisions, medicine and social sciences, humanities, and natural and technical sciences. So we have students anywhere from those who are analyzing data from the Large Hadron Collider to those who are doing like digital humanities and so on. So not everything is relevant for everyone. So we have a very simple prerequisite directed acyclic graph. So we start with the first module and then they have to do the second module. Mainly this covers both Spark and PySpark, with Scala and Python. And it essentially gives them some idea about ETL and basic stuff. I'll go into detail soon. So you can go to, so it says Introduction to Scalable Data Science, Distributed Machine Learning, topics Apache Spark, Scala, RDD, MapReduce, Ingest, Extract, Load, Transform, and Explore. With NoSQL and Spark SQL. This one is Introduction to Distributed Simulation, various supervised and unsupervised ML algorithms, linear algebra, vertex programming using Spark ML, graphics, and PyRDDs. So that's sort of low-level stuff with a very strong Scala programming introduction from scratch because we need to sometimes do heavy lifting in Scala until things are processed. This one is on legacy Spark streaming with discrete RDDs because certain operations still use them, and it's a nice way to introduce structured streaming. So you can come to structured streaming after the first and second module directly and skip the legacy streaming if you want. This is just, and then some of the examples in mathematical theories are on sketches. This is geospatial computing, scalable geospatial data science with Magellan, OpenStreetMap, GPS trajectory data, and so on. And this is Introduction to Deep Learning with Keras, TensorFlow, PyTorch, and PySpark. Topics include TensorFlow basics, artificial neural networks. This overlays the open courses from Google on Udacity, all the videos and stuff. So some students may have done deep learning in a single von Neumann architecture, single machine, and others may not have done it. So it allows them to read at their own pace, the depths they want or remember. And then, it has deep feed forward neural networks, convolutional neural networks, recurrent neural networks, LSTM, GRU, generative networks and patterns, reinforcement learning, real world operations, and MLOps, PyTorch and MLflow. Then this is privacy. So some of them have to worry about, this is GDPR in the EU. So how do you do privacy aware scalable data science? Topics include data standardization, algorithmic standardization, GDPR law and its implications for AI and ML pipelines. The complications of the right to be forgotten is kind of very unresolved, I believe, still. Pseudo-anonymization and differential privacy, minimax optimization procedures for locally private estimation. Some of that is theoretical, but a lot of it has code base. This is now distributed deep learning. So here we introduce, we go from standard deep learning on a single machine to distributed deep learning with Hoverboard over TensorFlow and Keras and PyTorch, DDL of various CNN architectures for image segmentation with Hoverboard, MLflow, and hyperparameter tuning with Spark trials. We will probably use more modern frameworks for that in the next instance. This one is, so there are students who are interested in sort of time series analysis from economics, finance, and other background. So how do you do signal processing of multiple time series using various streamable Spark code? So we did this thing, for example, a showcase on financial stocks and news events, where we pass the GDELT data from the raw source. And I'll maybe show some examples of this. So you can explore events of interest or persons of interest, look at oil price fluctuations and what news is possibly related. There is current project on a sort of scalable causal inference, but that's not released in code yet. And here is an example of 22 VASP PhD students in the AI track in the last instance, what kind of projects they did in the enterprise version of Databricks, which allowed us to actually attack quite a lot of different problems. And in fact, 2 of the project reports last time has actually ended up as publications. So this one was detecting slag formations with deep convolutional neural networks. This is a problem in LKAB, which is a mining company in northern part of Sweden, called Kiruna. And it's quite, yeah. So when you start melting iron ore, you get these slags, gunk that forms, and you need to make sure that before it gets too big and breaks the system, you need to have trigger alerts so that the operators can go and handle it. The other paper that was published by a different project in the VASP AI track was distributed training and scalability for the particle clustering method, uCluster. So this is something for the Large Hadron Collider data where they took a single machine process from a couple of years ago and made it distributed. So now let me go back to this current instance. The current instance, March, I forgot how much time I have left. So this instance will happen in March. It's open to Uppsala students, and we give them a landing page in our learning management system, which is a Studium-derived thing. And I've just simply embedded what I showed you here. So I control all of the information directly from GitHub.io. And they again can do these modules and so on that I described. In this case, we broke it into 4 modules, and HP is like number of credit hours. So the first module is 3 HP. So that's several hours of work. And this one is 3 HP. And then module 3, because they have different problem domains, this is where they can go and dive into specific parts, specific models of interest to them, and then form group projects and do the group projects. So this is the structure of the actual enterprise version. So the way I do the teaching is so that all these modules can be downloaded as DBC archive files, and they're tightly done so that they work in Community Edition also. So the plan is they learn in Community Edition, any of these modules, and then they mainly come here to do the projects. So this is to save costs. So for example, that 22 projects I told you, this was done in the last instance, they're all here. So they've done all kinds of analysis from sort of NLP processing of Swedish flashback, which is a social media, to scene graph analysis, to distributed ensembles, particle clustering. So this is the one that got published into a paper, and this is another one that got published into a paper. Right? So I won't go into these details. What I want to show maybe is this one. So basically we have notebooks and a Scala crash course, multilingual notebooks, because the industry in Sweden really wants the workforce to at least know 2 or 3 languages. And so Scala is one of the new languages most of them will learn. Most of them already know Python pretty well, and some know SQL, but and some know R. So we do these types of things here. Let's see. Yeah, so these are all the notebooks for the machine learning things. So we basically do some stuff here, and then for streaming, structured streaming, geospatial analytics, deep learning, distributed deep learning, privacy aware, and then this sort of trends and stuff. How much time do I have left now?
2 minutes.
Oh, perfect. So I have one last thing I wanted to point out is, yes, so this is heavily sponsored by a lot of agents, both academia and industry. So Department of Mathematics and the Center for Interdisciplinary Mathematics at Uppsala University has been funding the last 2 or 3 instances on the academic versions. And the voluntary autonomous software program I already mentioned as well. And Combion Mix AB so I also work there as a researching, developing, and enabling chair in mathematical data engineering sciences. So that essentially makes sure that the curriculum is tied to the industrial needs. So I wanted to kind of have a quick shout out. Next thing, I'm going to have Suprarek, who is an engineering assistant for the course, just talk about. Can you see the slideshow, everyone? Okay, go on.
Okay, we finished this very quickly. Okay, I'm Subrahman Kawatanawit. I'm working with Browse on SemiAutograder for SCAD course, and for the autograder, it just automatically grade the students' notebook, exam, and assignments. And we call it semi because actually in this process, the teachers can just jump into it to interact with each process to like adjust some scores or add extra cells to the student's notebook. And with the auto grading system, what you really need to have is the master notebook that include the course contents, includes the problem, include the test, the local test that students can test whether their answer that they give is in the right format, right digits or sensible range or not. And you need to have the solution cells and also the test that we use in our system to grade the system to check whether the student's answer are correct or not, and then we will give the scores to them. And with the auto grading system, we can also extract only some specific cells into a separate notebook. And what we actually need is that we want to have all of this we actually want to have all of this just except the solutions and the test cells in a separate notebook, and the autograder will just upload it into Studium, which is the learning management system of our university. And then the students can just download it, play with it, learn with it, and then submit the.
Yeah, it's very similar to what Robbie said.
Yeah.
It's slightly more automated perhaps, and it's slightly different from Udita's, because we want the students to have homework problems in Scala, Spark, SQL, R, and Python.
Yes.
And this is kind of the basic workflow, and we're in the process of actually making it work. So if people have any feature requests and so on, it'll be great. And at some point we'll open it, so it'll be a community effort. The main idea is that we have submission notebooks. It can be IPython or source notebooks.scala or just DBC archive is hopefully our plan. And then pre-process the submission, and then basically use some Dockerized environment for auto grading. And in the event that the problem sets are too large, then we use Databricks CLI to actually do the grading there. All the students submit it through the learning management system. So we are working on the back end to automate all of this. If you're interested in details, you can go watch this YouTube video. Because we are trying to create a universal notebook format in the algebraic representations of Haskell overloading on Pinot. So no matter whether you work on Databricks or IPython or whatever, there is a superset of all representations, and that's what we are going to go through. That way we can go from Zeppelin to Databricks or vice versa, because that's how we've architected it so far.
Okay.
Thank you very much.
Thank you.
Super, Art. Thank you, Roz. Thank you. It's one thing that I want to mention to the audience is, and this is what made me think of it, is when you were talking, Robbie. The Databricks Academy is the training and certification arm of Databricks, and they set up all of their self-paced learning as notebooks within Databricks in much the same way that you set up your courses. I'll put a link to that in the chat window. And what made me think of this was Brennan, who was on the call, at least at the start. It's like Databricks, the company, is changing over their learning management system internally and externally. So the process by which students can get access to these courses has changed. And basically, if you're at a university, we can set up your domain name. So at vanderbilt.edu, anybody with that email address can go and take those self-paced learning courses for free. I'll put the link in the window. It's a manual process now. You fill out the form, and then I have to go and ask for forgiveness and or permission to allow this domain to be openly used for the free access. But it's a couple $1,000s worth of courses, and it can be useful. So I'll put the URL in the chat window to everyone on the Zoom, LinkedIn, and YouTube link. So it's just a Google form that Rob put together, but at least it gets the process started. All right. So any questions specifically for ROS and SuperArc? I love seeing this auto grading conversation. It's something that we've been talking about for almost 2 years now, since before the program started. So I'll be quiet.
Yeah, I'm just checking to see if there's any other additional questions, and looks like everyone's answered them so far. I know we added a few links from the presentation, so we'll make sure I'll update the event copy too, and the YouTube copy with these links. So folks, good.
Oh no, I was just going to say, if I could make one more request of the presenters. If you have a copy of the syllabus for your course that you could send to me in PDF form, or I was waiting for that reaction, or even if it's just a link, what I will do is I will put that in my curated list of content that we provide for the Databricks University Alliance members, so that I think, and I give Cliff credit for this. I'm going to put the link to the doc in the window as well. It's a great way to share information, but it's really hard these days to get access to course syllabi given the miscellaneous online learning systems. So if you can share your syllabus, I will add it to this document that I just put in the chat window, and I'm putting it on the LinkedIn chat as well. And basically, this Google Doc is a curated set of resources and context for the Databricks University Alliance program. It's just resources available to faculty. And the other thing I want to say is that internally within Databricks, they like the fact that there are lots of people in the program. For me, it's a service to faculty. Everything is free. There's no commitment on your side. There's no commitment on my side. It avoids this sort of quid pro quo sort of thing. So the link that I put, anybody can get access to it. And I'm open to suggestions as to how to improve the resources and the connectivity between faculty. I'm most useful as an instance of the finger post. It's just like, this person knows that, that person knows that. So.
All right. Okay. I think with that, we'll close out our session for today. So first, I just wanted to thank all of our speakers. It was great hearing about how you're using Databricks in your schools, and we love that you're part of the program. And thank you everyone for joining us today. And I hope that you check out our meetup group and check out upcoming sessions. I also dropped the recording link, so that's available. And if you missed it, feel free to ping me directly on LinkedIn or in the meetup group. So with that, I hope you all have a great rest of your day, and thanks so much. Take care. Bye.
Thank you. Thank you, Karen, for making this work so well. Thanks, everyone.
Thanks.
Bye.
Bye.